Welcome, I'm Mark Yedlin, and I have the pleasure of moderating this session, Session 2C, Emerging Technologies. Our first two speakers are Chuck Hixon and Kevin Gilson. Chuck is not only a good friend, but he's considered an expert on 3D database-driven applications for planning and design. Mr. Hixon has authored the synthesis study, Visualization for Project Development 361, for the National Cooperative Highway Research Program. He was also a founding board member for the Transportation Research TRB Committee on Visualization and co-chairs the Civil Integrated Management Subcommittee. His co-presenter today, Kevin Gilson, is the Director of Visualization for WSP's Project Visualization Group. Kevin manages 3D modeling and visualization programs for large infrastructure projects worldwide and has experience with a broad range of computer applications for planning, design, construction, and visual communication. For the last several years, Kevin has helped promote and implement innovative technologies, including real-time interactive presentations, augmented and virtual reality tools, mobile 3D applications, building information modeling workflows, and 3D model-based design solutions to support planning and communication efforts on large transportation projects. So it's my pleasure now to introduce Chuck.
Thank you. Good afternoon. How are we doing? Everybody awake after eating all that food? You're all lying. Hopefully we'll wake you up. It's tough to follow Kevin's intro there. Sounds pretty important, but I'll do my best to live up to that bio. Wow. Today I'm going to talk about BIM for infrastructure, or what we've coined here in the highway world as SIM. Same thing, just different terminologies. And I'm going to talk about the trending of why we're heading in this direction, into some of the issues that we're dealing with, and maybe spur you on to think of how to handle some issues as we go into the future. So this is one of my favorite shots, and I showed this yesterday during our SIM subcommittee meeting. You know, why do we need all this fancy new technology? Well, it's a good reason. We're not sitting on the floor putting 40 plots together to convey a complex issue. These technologies are certainly making it easier for us to understand. And this next slide is a good slide to help you understand the impacts through some simple data analysis, which I'm certain if Mike Pack was in the room, he'd love that. So let's kind of get your brain thinking a little bit after eating those delicious cookies. So the world population, as of a couple of years ago, 7.2 billion people, and projected to be somewhere between 9.6 and 11 billion people in roughly 30-something years. And we hear the numbers now, billions, trillions, and it really doesn't mean anything. So let's put it in a context to help you understand. So in 35 years, where are 3.3 billion more people living? And it's projected that the migration back toward urban areas will continue. So cities are going to grow, and grow substantially. So we got to build houses for 3.3 billion new people. So to put it in simple context, we need 33 million buildings, and we'd have to start building them this year at a pace of 2,600 buildings a day to achieve that number. And then we could do some quantitative math and work it out even more. So the point of this slide is there's a lot of infrastructure in the future that needs to be planned, designed, and constructed, and these technologies are needed to help put all that information into a context that not only can we understand, but more effectively utilize. Again, with more information, you make better decisions. And that's really the premise behind all of these design technologies, as I like to call them. So a lot of pushes out there, and you probably have heard a lot of these terms over the last year, everything from VDC to BIM to BRIM. I work quite a bit in the building or vertical side of the world, and almost everything we do is in 3D. And typically, that 3D information is linked to some sort of database so that we can do some assessment, either with the design itself or potentially for cost into the construction, or even as far ahead as into operations and management. And I'm certain on the civil or horizontal side, you're gonna start to see that mindset as well. There's a tremendous amount of new technologies out there that we're all grasping with how to use it. For example, everybody knows about a drone and how easy it is to fly one of them, but it's not so easy to get a permit to fly one for your project. Or are you licensed pilot to fly the drone? All sorts of issues with the technology that still need to be figured out as well. So these are all things that are pushing us forward. I think more importantly is a lot of gray hairs like me have got to learn to change the way we do things, because the rules of yesterday do not really work that well today. For example, the world's greatest publisher is Facebook, and they don't own a printing press. The largest taxi company in the world is Uber. They don't own any vehicles. So we're all doing things differently today, and we need to change or will be changed. I live in Rochester, New York, which is the home of Kodak. And in 1980, Kodak employed about 65,000 people just in Rochester. And today they employ 1,500. And they certainly didn't change with the times. And there's a lot of technology out there, from typewriters to VCRs, where if you don't change and adapt, you go behind. So the push here is we have to migrate to these newer technologies so that we can change with the technology that's around us, including the Internet of Things. Everything is trending to be integrated into one holistic location, we'll call it. Google Earth is a good example of a global tool that allows you to do simple things, either locally or macroscopically. And the last thing I'd like to talk about this slide is there's a lot of talk and discussion about automated vehicles, and it's not science fiction anymore. That is coming sooner than you think, and we need to be ready for that. How are we going to design in the future with these new technologies and make them work? Where I see a tremendous use in this type of technologies, or I'll call design technologies, is in the construction field. And the reason why its use is prevalent there is that these entities are profit-driven, and these tools make them money. Anyone that's worked on a building project using Revit, for example, we sit through coordination meetings and we discover all sorts of design issues or construction sequencing issues. They're all worked out virtually, and at the back end, the savings is tremendous for these constructors. Huge savings by understanding the design better. I think it's probably a hurdle as to why we haven't adopted it as readily in the transportation agency community, because those agencies are more procedural driven, not profit driven, and so the motivation to migrate is not as urgent. I actually have a lot of supporting documentation. I actually can call some of this up to help back what I'm talking about, and if you want some of that documentation, just come see me afterwards and I can either copy it for you now or I can email it to you as well. So SIM, or Civil Integrated Management, that seems to be the term that the FHWA is adopting, and I think it's a fine term. The only thing I don't like about SIM is I have to define it whenever I tell you about it, versus if I say BIM for infrastructure, you pretty much know right away what I'm talking about. Also, if I go into Google and I type SIM, I get information that's spread out all over the place. Some of it's really good, some of it's not so good, and I'm hoping through our SIM committee we can help rectify that and somehow produce a location where you can go for SIM guidance. To me, it's a big issue right now. But there's plenty of resources out there. You just got to find them. Best practices as well. If I type in BIM in Google, it immediately brings me to several forums where I can get all sorts of guideline information. I can find out about execution plans, how to do them, what, for example, is defined as level of detail or development. I can get that information right away. And this is where I'd like the SIM community to do the same thing. But they're out there. And I think those places are a great place to start as well, as far as trying to get information. We discussed yesterday in our subcommittee meeting that, how do you develop standards and guidelines when each region within a transportation agency is unique from the other? And I think what needs to happen is there needs to be a base set of principles and guidelines, and then every project should do what's called a project execution plan. As you see here, Penn State has developed this portal, and you can go there and get sample execution guides, and they basically walk you through the key things that you should do before you start your project. And the premise there is, what is the end deliverable? And then you reverse engineer your workflow based on that end deliverable. An issue I commonly see in our universe of visualization is that it's thought of somewhere along during the process, and that's quite inefficient if you are going to start up a visual project 2/3 of the way into something. A lot of times you're redoing things. So planning ahead of time is certainly key. And, as I mentioned, level of development, there's probably 30 definitions of that. These are from the recent AIA. But again, what level of development means to you can be different for other agencies, or again, project by project. The Kew Gardens interchange and the K Bridge in New York City for NISDART Region 11 have 3D CAD standards. And they're very specific 3D CAD standards, including level of development for bridge, for roadway, for terrain, clearly defined out so that as the project goes through, everybody's aware of what the deliverable is. So it's important to have that plan ahead of time. I'm working on a large project in New York City for the LaGuardia Central Terminal project, and there's a myriad of software programs being used, and that's just the reality of how we work today. Not one application works for everything. So how do you tie all that information together? Again, if you think of the deliverable end and work backwards, you can come up with a process to tie all these elements together. And then this is kind of a sample of the BIMX plan that was done for LaGuardia. I can show you the standards and guidelines developed by the Port Authority for BIM, but I can't show you the plan itself. The other thing I commonly deal with, I consult for a lot of different architects, engineers, and constructors, is you also need to plan for the infrastructure involved with all of this technology. Using an application such as Revit for your BIM app is critical. But Revit itself requires some demanding constraints on the workstation end. If you plan on running Revit over a wide area network, you better plan ahead for that, because it doesn't run effectively on a slow bandwidth network. It really needs some high-speed performance, which means you need to get some WAN accelerators and stuff like that. If any one of you have ever laser scanned, you will know that you can gobble up disk capacity in mere minutes by scanning a project as well. So you need to decide ahead of time, where is that information going to be stored, how's it going to be accessed, and how's it going to get backed up. All things that need to be thought of, because there are different technologies in the past. I used to be the IT director of a company, and when I first got there, the entire storage capacity was 3 gigabytes for everything, for every office. 3 gig. And, today, shoot, that's not even one file in some cases. So times definitely have changed. I love this slide. There's so many Ds out there. I think there's an 8D somewhere. I don't know if anybody knows what it is, but I'm sure there'll be more as they come. I've heard different definitions for the Ds, but the premise holds true where you need to think beyond just the geometry now. What are you doing with that geometry? How are you making it smarter? Again, to me, the power of a product like Revit is I can make it do much more than just be my design. And a simple example is we'll work on a project and the facade of a building is going to be brick. So as we design, program Revit to calculate and tabulate the cost of the brick as we go. This is quite effective if you're working on a design build project where you need information pretty much in real time. And that's what Revit allows us to do. Every day we know how much brick it's going to cost as we keep going. And it also means that as we exceed some of the constraints that are set for the project, we can make better design build decisions. Do we change the design? Do we change the materials? Those things are all essential when you're talking design build. So all these Ds fill into that, from scheduling and estimating and on down the line. And I've heard a lot today, and I heard a lot yesterday, that people want to see a life cycle approach, and that's kind of what SIM is. It's in planning, but through operations and management. I think the way we work today is quite inefficient. We plan and we use tools to plan, and then when that plan gets approved for design, we almost throw out most of the information, and then we design it, and after we're all happy with design and it goes to construction, we almost throw out a lot of that information and redo it again. So very inefficient, and if we are truly trying to save money and get projects done more efficiently, then we need better processes to do so, and that's kind of what these Ds are trying to achieve. So I had mentioned the Kew Gardens, and I just kind of like to give a reference as to there's definitely a lot of thought out there, and it's hard to find this great information. I was privy enough to be on this project, and I kind of want to get out of this for a minute and actually call up the specs. Hopefully, yeah, here we go. Just to give you an idea. Oh, I got to accept. Oh my goodness. So these are the 3D CAD specifications, and I'm just going to kind of get into it real quick here to give you an idea of where things are heading. This particular project was nice enough to actually define, oh dear, we'll just kind of put that over there. Definitions of what they consider to be a 4D model, which to me is critical. Again, why is this doing this? Hopefully I get something quick before it blows up on me. Yeah, won't be the first time. I'm trying to get up to some of the level of detail for you, so bear with me. But as you can see, it's incredibly well thought out. Phil Bell, who's not here, was involved in putting a lot of these specs together with Kevin Gilson's company, WSP, putting a lot of these standards together. And it's incredibly helpful for me as I go through and I know what I need to do. Again, they defined in their terms, not what the AIA's LOD definition is, it's the definition for this project. This is not a universal standard and guideline document, it's the execution plan for this project, and that's something I can't stress enough. So as I go through, I know what's clearly expected of me. For example, the level of detail for ITS. I don't have to be extremely detailed as we model it out in 3D. And this is for the design itself. This isn't for visualization, which I want to stress. So, all right, let me try to get back in here real quick. How am I doing for time, Mark? 5 minutes, all right, I'm getting hooked. I love showing these things. These are actual solicitations that have been released by the FHWA through the FHWA site, and there's a lot of thought out there on SIM, specifically this one, looking for standards and guidelines, and I'll be very excited about what comes out of this advertisement. My only complaint is the speed of development that I stressed again yesterday at our committee meeting, is that This project's 24 months before everything's released and published. And we all know in 2 years, we'll probably have automated vehicles running around by then. So waiting that long to publish is, in my opinion, fruitless. We really need to stress to increase the veracity of our research. And then 2 other ones, again, the design technology pushing us. You've seen augmented reality examples out here. Well, they're getting pretty serious. How can we use this technology to help us? And the same thing with drones or unmanned vehicles. How, again, do we use this technology? We need to document it and see how we can come up with a better workflow process for the use of that kind of technology. So in closing, lessons learned that we've experienced, and I know others have, is, every project's unique, and it really needs its own set of standards and guidelines, which can be based off a fundamental group of standards and guidelines. I think SIM itself has not been fully adopted yet because we're trying to solve everything, and it's so hard to solve everything. And everything can be from the design itself to the governance of that design. There's a lot of variables out there, but we need to move forward, and to me, that's through the SIMX plan. And again, better communication, which I think is through some sort of universal portal where you can go for information on this and get that information easier than we can today. Again, I almost would like to cheat off the AIA website, which is a great resource. So for the future, we need to continue to develop standards and practice, and I don't think we're ever going to have them. I like to study history, and I'm so old that I was the guy that was pulling out the drafting tables and bringing in those huge dual screen beasts at the advent of CAD. And there were no level of detail or any of that when CAD first came out, but people made it work, and we really need to do the same today. And I think that's it for me, right? Am I getting the hook? And I've got to blatantly sell our committee off. There's a lot of documentation out there, and I have it that I can give to you on SIM already. A lot of good initiatives have been done through our committee and other committees within the TRB itself. So a lot of good stuff happening. So I'll move on to Kevin. How's that? I'm just trying to get rid of that. All right, it's all yours.
Hi, good afternoon. Thanks for letting me present here. Hold on. So I'm going to talk a little bit about a role that WSP plays in projects utilizing some of these 3D workflows you're talking about. I want to introduce the idea of an integrated project model. We've talked about all these different workflows, CAD workflows, bringing in GIS data, LiDAR models. The way we like to approach a project is to think of those as inputs to an overall project model, and then outputs from that project model support different benefits to the project or different aspects of the project. And that's, as program managers for large projects, that's one of the opportunities we have at WSP. We aren't the designers necessarily, we're working for the owner, helping them understand the implication of the various designs involved in a large project. We're also on a project I'm going to talk about shortly, involved in the public involvement program for the project. So we're managing the design, we're also managing the communications program for the project, for the client and for the local community. This is the Walk Bridge project in Norwalk, Connecticut. It's on the northeast corridor, busiest transit corridor in the country, and they're replacing a 100-year-old bridge with a new lift bridge, since it still has to accommodate water traffic under the bridge. HNTB is the designer for the bridge, a lot of the track work, and then there's a variety of other consultants involved in various aspects of design. And as you can imagine, it's in a small northeastern community with a lot of old infrastructure, very tight site, water issues, coastal issues, so a lot of different stakeholders. And what we've tried to do with this integrated model for the project is provide a tool that can support not only construction planning and design, but also the communications program. So there's sort of two pieces of the model that we're providing to the team. One is an interactive design model that we keep up to date as the design changes. In this case, we're using Navisworks for that. And that model's provided to the team. And there's a model manager that sits in the design office and manages this model as it evolves to coordinate planning meetings and construction meetings. The model's also being used to produce visualizations to support stakeholder communication. So this model encompasses a couple of square miles, and it's been kept up to date as possible, both in terms of the existing assets on it, to start looking at demo, and future assets that are being designed. The client, when the project first started, did mobile scans along the tracks. They had a unit on a train, and they captured LiDAR data along the entire corridor. And the design consultant, HNTV, used that data to capture cabling and electrical work because they're designing the systems for it and also the demolition of these existing wires above. But we were provided that LiDAR data as part of our Navisworks model, and we used the same data set to capture existing structural elements that we wanted to put into the Navisworks model to support the contractor in figuring out how to lift these pieces out, how to demo them, as well as just to support the context model to show the overall project in its context. More recently, the client has started scanning structures at grade, because a lot of the old bridges on the corridor are going to be replaced, which involves civil work at grade and structural work to replace the bridges. Those are being scanned with newer technology that allows RGB scans that come in not only with accurate point data, but they come in with color data that allows us to produce an almost visualization quality model directly from the data. So this is the Navisworks model that we've built showing context, and we've started incorporating chunks of the LiDAR points that are being scanned at grade into the model. And there are a lot of historic structures along the alignment, and the community wants to retain that character, the old stonework and the ironwork. And so we're now working with this new data set to capture surfaces of these stone abutments so that we have a record of the exact configuration of the abutment, whether they rebuild it with the existing stone or whether they try to replicate it with some kind of artificial, either concrete or new stone. This is all point cloud data, but it's in Navisworks, so we can measure it, we can cut sections through it, measure dimensions. The model is also being used, as I said, to illustrate different proposed construction staging plans by the contractor. And these are brought into meetings, and all the equipment in this model can be moved around in real time with the contractors and the designers together to come up with these different schemes of where they're going to place equipment, where they'll place temporary structures, how they're going to bring this stuff in on the water, and then what is the overall construction scheme. As you can see in this case, they're going to build half the bridge on one side, keep the existing bridge open, and then eventually demolish the northern half of the existing bridge and replace that as well. And there were several different sort of overall schemes that were being looked at, which all affected how material was brought in on the water. We could take that model and then in parallel manage our visualization model, which allowed us to produce higher, more visually realistic renderings of the construction to bring to public and stakeholder meetings. So several times during this planning phase, we would develop these construction staging renderings from several viewpoints to show the client and stakeholders what the construction methodology was, how it was going to look from different key locations. There's a lot of public facilities along the water that were very concerned about what this was going to look like during construction, how are people going to get in and out of the location, how are they going to wheel it in or float it in. And then the next step, which we've just begun, is to start taking that Navisworks model and now get a contractor schedule and link it in and start developing a true 4D model for the site. We're also working with the designers to look at various alternatives for design approaches. The community wants to understand what is this going to look like, and there are several different ideas for the tops of the towers, the girders, design elements. And every time a new design submittal is made, the model stays in line with the designers to show those proposed alternatives. Oh no, I must have done a link rather than an insert on this animation, but I just wanted to show that one other thing we're exploring is using this VIZ model to produce VR applications so that people can experience this much more realistically. And we've got examples of this right here. We have a real-time model of the walk bridge that you can walk through. We have a few renderings that are done with panoramic images. This is just kind of fun as an animation because it's got the warp that you see when you render panos. So I wanted to show one other just interesting project that also uses a series of different assets. We had a rough model of downtown San Francisco along Market Street, and we were asked to support a project called Light Rail, which is going to be, a string of LED lights along Market Street that are designed to track underground transit traffic. Like when a bus or a train goes underground, this LED light will stream down Market Street to show you that there's a vehicle underground. But as part of this, we're doing the MEP for it. We had to decipher the catenary, or the overhead contact system for the bus system. There's no as-built for those. They're just schematics that then the contractor installs. So we worked with Autodesk, who did a mobile scan of all of Market Street, and we used that point cloud to capture the network of overhead catenary wires for the entire alignment, and then use those to design how this LED string would be strung from the structural wires. Half of the wires are holding the wires, so the half of the wire network is a hanger wire, and the LEDs were designed to hang from those. As part of that, the fire department wanted to know where they were going to install removable sections of the wires because they had to access locations with ladders. And so they wanted us to create a model that basically showed where buildings were higher than a certain height. I think it was 75 feet. So we used that same point cloud to just quickly go through and measure rough heights of buildings, and we could quickly create a schematic model that showed Market Street and what buildings would potentially need to have a different design for the wires to accommodate fire vehicles. So just a nice example of a very small model where, again, we could kind of mix different types of data and produce a couple of different visualizations that supported the design. So, any questions?